We're going to get started in 1 minute.
Should turn it off. All right, guys, let's get started. This is our first class. What is blockchain and class logistics? So I'm Aditya. That's Jake over there. And this is Tiffany. We'll be teaching you guys this semester about blockchain fundamentals. So let's get started. The contents for today, we're going to do some introductions and logistics. We're going to go into what is blockchain, distributed ledgers, trustless consensus, identity, and then we're going to wrap it up with transactions. Also, let me know if you guys can't hear me. So yeah, class logistics. I'll sit on this side, actually. So the structure of the course, every Tuesday from 5 to 7, we'll be meeting here, which is Genetics and Plant Bio 100. I know it's super far, but it's the only room that we could get. And lectures will be usually like an hour to an hour and a half. And we'll be giving you guys a 5-minute break, so don't worry about it. You know, you need to stretch, go to the bathroom, all that. And the recordings will be available on B courses. So if you go to the class on B courses and then go to Media Gallery, you'll be able to find all lectures. Like, please give us up to 1 day to upload them, but yeah, you should see them up there. And then attendance. So attendance is mandatory for enrolled students. This is 25% of your grade. And you can make up your attendances using the Google form on the syllabus. I'll get in more to how we track attendance in the next slide. Please do not email us to update your attendance grade. We might take a day, but we will make sure that it is updated accordingly. And this course is 2 units, and you can also audit the course, which means that you can do all the assignments, watch all the lectures, but you won't officially be enrolled in Cal Central. A typical week of the class, so before Tuesday 5 p.m., you guys will have the chance to submit that Google form if you missed the previous week's lecture. And you should complete an optional reading. These will all be posted in the syllabus. And for Tuesday 5 to 7, again, just lecture and then complete the lecture assignment. So after each lecture, we will, I believe is it already posted, the assignment? So the assignment will be posted every morning. And you just come to lecture, watch the lecture, and at the end, we'll give you an attendance code. And you'll go into that assignment, type in the attendance code, and basically say you were here. And that's how we'll track attendance for the remainder of the semester. And immediately after lecture, the quiz will be released, and it is due the following Monday. So it's not due before class, but instead 11:59 on Monday. And there's office hours after lectures until 7 p.m. So whenever lecture is over until 7, just any questions you have will be up here for, 30 minutes. And then if there's a discussion post released, it will be due 2 weeks after, but discussion posts will be coming later in the semester. So when that comes out, we'll talk about it then. So the goals of the course. We want to make sure that you guys have an understanding of blockchain through running examples. That's honestly the best way that we see to teach it. There's through examples about all these complex topics. And we want you guys to be able to reason about unfamiliar technologies. Blockchain can be very complex and daunting. However, we want to make sure that you guys are equipped to learn about everything in the space. And also, we want to give you guys familiarity with trends and notable projects in the industry. Blockchain is a very emerging space, and there's a lot of cool things coming up every single day, and we want to make sure that you guys are all informed about everything. And also, confidence to pursue opportunities for contribution. As I just said, there's a lot of places where you can get involved in a lot of initiatives that you guys will be able to engage in after you take this course. And interaction with the club. I'll go into more about what we blockchainers at Berkeley do here at Cal and outside. So, yeah. and what we'll cover in this course. So understanding blockchain, this includes the history, how it works, how it's used, and also how it's misused. Blockchain beyond Bitcoin. I know a lot of people, when they hear blockchain, they think Bitcoin or crypto. However, this technology is very beautiful technology, and there's a lot of use cases that we will make you guys aware of. And this includes, distributed systems, Ethereum, scalability, and we will also have some guest lectures and special topics, which is to be decided, and this will be closer to the end of the semester. Got it. What this class is not. So this is not an attempt to convince you guys that blockchain is amazing. All of us here, we are very passionate about blockchain, but we will never tell you guys that blockchain is the best or try to force blockchain. At the end of the day, we're educators, and we just want to teach you about this beautiful technology. And again, coding and building stuff on blockchain, this course is mainly for learning about the fundamentals and how it works, but not how to implement it. For that, we have a dev decal. And if anyone is interested in that, please, after class, come up and we can talk about how to enroll in that. But that will teach you more about the coding, and you'll learn Solidity. What else did it cover in that? You'll learn about coding in blockchain. And not investment advice. So I personally do not invest in crypto. So if you come up to me and ask me about investment advice, I will not have anything to give you. And this course is not about that. This course is about learning blockchain and its fundamentals, not what to invest in. So who are we? We are Blockchain at Berkeley. This is our mission statement. Blockchain at Berkeley drives innovation in the blockchain industry by building an ecosystem that empowers students to make an impact through practical education, consulting for enterprise companies, and conducting open source research. Some accomplishments from our members: we founded the Berkeley Blockchain Accelerator. We contribute to Bitcoin Core, Cosmos Core, ZK Snarks, and a lot more. One of our members helped find Decrypt Capital, which is a $20 million investment fund. Another one of our members helped found Open, which is DeFi, derivatives and options trading, and they have $8.9 million raised. And then we also help coordinate SF Blockchain Week, which has around 5,000 plus attendees daily. And finally, one of our members helped find She256, which is for promoting diversity in blockchain, and was featured on Newsweek. Here are some of the startups created by our members since 2017, so we have some pretty significant names on there. And so here are some of our previous consulting engagements. We've worked with, right there, that's Osmosis, PayPal, UNICEF, Microsoft, Compound, so a wide variety in the industry. And, well, so this is more info on our blockchain, Berkeley Blockchain Accelerator. We are the #1 university blockchain startup accelerator in the US since January 2019. And we are the only university blockchain accelerator to offer a student fellows program. So if you join the club, you can be a part of that. And it's a gateway to the #1 university, US University for Blockchain. I think MIT might be #1 right now, but we're going to keep this up. And yeah, we had a record in 2023. We had 360 plus finalized applications with 520 plus in process. And here are just some numbers. So yeah, at the end of the day, we are a mission-driven organization, and this is just one way that we help fuel that. So I'm going to pass it on to Tiffany now.
Okay, so welcome to Blockchain Fundamentals. I'm going to be talking a little bit about the history of the course. So we started in the fall of 2017, the Blockchain Fundamentals decal. Our goal was to promote knowledge of blockchain technology in the Berkeley community and beyond. Our first class actually only had 23 students enrolled, and we tracked enrollment on a sheet of paper, which you see over there, and this was the class, and clearly the size has grown over the years. So that leads me to where we are now. Currently, we have over 100 students enrolled in this course. Enrollment has expanded 4 times since fall 2017, so that's really great to see. We also have a globally accessible MOOC through edX, so that's also going to be on edX. You can go check it out, but it's pretty much the same content as we're going to cover in here. We also created a Blockchain for Developers MOOC this semester. That's going to be synchronous on Zoom, Thursdays 4 to 6, but the information isn't up yet. But if you check it throughout the week, it'll be posted sometime this week on our Blockchain at Berkeley website. So it's important to talk about the wide spectrum of blockchain opinions that we probably have in this room and, of course, beyond. In this course, we're not going to be focusing on who's right. Instead, we're going to just delve into the technological aspects of blockchain, the philosophical aspects of blockchain, and you'll get to decide for yourself where you lie on this spectrum. Here are some other blockchain classes at Berkeley. So not all of these are given by Blockchain at Berkeley, but the first one, Blockchain for Developers MOOC, that is something that we're offering this semester. The 3 classes below that, that's offered by other professors at Berkeley. So if you're interested in any of those, you should check them out either this semester or next semester. And of course, again, the fundamentals on edX, which has over 200,000 students from 193 countries, which is so great. Are there any questions about logistics or about blockchain at Berkeley, anything like that? Perfect.
All right, so now I'm going to be talking a little bit about what blockchain is. And then the first thing before we need to talk about what blockchain is, we need to talk about centralization. And ultimately, centralization is authorization handled by a single party. I'm going to click this one. All right. Can you guys still hear me? Or is it hard to hear me? All right. So what is centralization? Basically, centralization is this idea that everything goes through this one middle party or like a single party. And you want to think of this as like data stored by a single party. So think client-server networking, hierarchical org chart, political dynasty, central bank, which is like a pretty popular one when we think about cryptocurrencies, blockchains, and overall centralization. And then like some sort of figurehead that ultimately everything goes through. So with centralization, there's obviously many pros. There's a reason why we use central banks as one of our main banking systems. So some of the pros, I guess, are efficiency. With data stored in one place, it's easier to access that data. There's less people you have to contact, and it overall just makes it more efficient. Same thing with easy updates. You only need one stamp of approval, whereas as I'll go in later, somewhere like decentralization, where you have multiple parties, you'd have to get all of them to stamp off on that and approve that. But obviously, with centralization, there are many drawbacks and cons. The first one being the lack of sovereignty. With one central data, you're kind of controlled by that central party, and you don't really have control over your data because they can kind of do what they want with your data, and you really lack that sovereignty. And then going off that one point of failure is that if you're hacked or anything happens to that central party, you're going to lose your data. So if that bank is hacked, then you might lose your bank account password or something like that. So with that kind of brings up the question of how do we combat this centralization and what's like a good alternative to it? So ultimately, we're in this blockchain class. We're going to talk about decentralization. And what exactly is this word decentralization? I'm sure you guys have heard it 100 times when thinking about blockchain and Bitcoin. But ultimately, it's authorization according to an openly known protocol. And data is stored by the participants. So this idea of data being stored by the participants, essentially that each person is going to have their own copy of the data, of the ledger. And by doing that, you have more control over your data. And it's not controlled by one central party that could go in, edit your data, and make a change without you noticing. Because every participant has your data. If any change is made, it's going to be approved by everyone, and you're going to know what happens. So when thinking about some pros and cons, you have sovereignty, and you know exactly how your data will be used, and you also have fault tolerance. So basically, if that central bank gets hacked or that one person gets hacked, you're not in trouble because you have a lot of people with the same amount of data, and they can help recover that data, and you won't be as at risk. But with this, there's inefficiency. You have to contact every single node or every single participant within the blockchain to get your data changed, and that can cause it to be really inefficient. And then similarly, with having to contact a bunch of people, it's difficult to update and make changes to your data. So just some quick definitions. I'm just going to read over these. Blockchain, a distributable, immutable ledger that records transactions and tracks assets in a network, stores data in a way that allows multiple parties to access it reliably without having to trust one another. And we'll talk more about what all these definitions mean, but this is just kind of a high-level overview of this term blockchain. And then obviously with blockchain, you've probably heard of cryptocurrency, which is a form of currency that's stored completely digitally and isn't issued by a central authority. And so basically, there's a lot that goes into making this cryptocurrency combined with the blockchain. And the most famous example is Bitcoin, and we'll be talking more about this in like later lectures. But yeah, so I guess ultimately we want to talk about why blockchain was derived and how it came to be. And it came from this idea that our financial system was centralized. And for many, they thought it was a problem because, you know, with banks, with that centralized financial system, we have a problem of no accountability. We can see this in like the 2008 crisis where banks essentially screwed over a lot of people and ultimately got bailed out by the government because of this central authority and the lack of ability to have control over your own data. And we even see this in like other cases where we have the Facebook Cambridge like incident, and then the Snowden, and then the NSA incident. And then so ultimately it's in banks we distrust, and I kind of talked about earlier, but yeah, we wanted to find some alternative to banking that would allow us to have more control over our data, over our money, and not be susceptible to any hacks or any like centralized system. So yeah, the first thing that came about, and probably the most famous cryptocurrency, was called Bitcoin. And essentially, it was this cryptocurrency created by Satoshi Nakamoto in 2008. And he thought there was like a problem with banks. He didn't really like the centralized authority. And the original use of this data structure is known as a blockchain. And that's ultimately where this idea of the blockchain derives from, and inspired a lot more from there. And so yeah, so a few Bitcoin components: identity, transactions, distributed ledger, trustless consensus are the main 4 things that derive Bitcoin. And next lecture we'll be talking a lot more about Bitcoin, but this is kind of just a high-level overview of blockchain and Bitcoin. So are there any questions? All right, cool.
All right, so now we're going to be talking about the distributed ledger. So I think this is one of the most important parts about blockchain and understanding how the structure looks and how it works in general. So let's talk about the record keeping in a traditional model. So in a traditional model, data is stored and updated by one central entity. So for example, the bank. And the bank also has security measures in place that prevent hackers or failure of the system. So let's say Diddy wants to send $3 to me. He asks the bank, can I send $3 to Tiffany? The bank is like, okay, that's fine. Then Diddy sends his $3 to the bank, then the bank sends his $3 to me. And so we all trust that the bank is gonna do this transaction and perform it properly, and that at the end, I'm gonna have Diddy's $3. But on the blockchain, we're trying to eliminate the bank, eliminate that one central entity so that Diddy can just directly send his $3 to me. So that is where the distributed ledger comes in. On the blockchain, data is stored by and updates are broadcasted to everybody. This is transparent and fault tolerant by design. So let's do another example. So let's say Jake, Diddy, Rithika, and I, we all decide, okay, every Sunday we're gonna go to brunch together, okay? But every Sunday we don't wanna keep, like sending money to each other, and that's just really annoying. So we're like, okay, Jake, how about you pay for all of brunch every Sunday, and then at the end of the month, we're just gonna be like, okay, let's all send the money we owe to Jake. And so we're like, Jake, write in your notes app every time we eat brunch, be like, okay, Diddy owes me $5, Tiffany owes me $3, Rithika owes me $1, whatever. But then at the end of the month, we realize, oh, I think Jake is charging us a little bit more money. So that's not good. How about let's change our system in that after brunch every single week, all of us write down the amount of money we owe Jake. All of us write down. So I'll be writing down how much Diddy owes Jake, how much Rithika owes Jake, and how much I owe Jake. Then in that case, at the end of the month, we get to see that all of us have the same exact record of what we owe Jake. So then we can compare them to make sure that Jake isn't scamming us. So this is the blockchain. Transactions are bundled into blocks with backlinks to enforce an ordering. So in this picture, you can see all of us have the blocks. Those are the exact same copy. And then we have once you add a block onto the blockchain, it links to the previous block, and that block links to the previous block before that, so that everybody has the same ordering of all the blocks. Are there any questions? Yes. Yes, exactly. So the question is, if you have multiple transactions happening at the same time, then you don't really know what order the transactions are happening in. Is that correct? Yeah. Okay, yeah, so we'll get into that a little bit later in later lectures, but for now it's important to know that whenever transactions are not in a block, they sit in this place called a mempool. So in the mempool, people get to choose transactions from the mempool that they think are valid, and then from there, they would include it in the block. So even if you have the transaction before somebody else, your transaction might be added to a block before the other person's. Yes? Yeah, so we'll get into that in later lectures, and I'll get back to you on that. Any other questions? Yes? Yeah, so you can think, for CS majors or like anybody who's taken CS, you can think of it kind of like a reverse linked list. And they would be between the blocks. Correct. Yes? Right, so we'll also get into that in later lectures and maybe even in the rest of the lecture. But hold on tight to your questions. Anything else? Okay, wonderful. Okay, so now we're going to be talking about trustless consensus. So the motivating question is, now that I've recorded my transaction, how does everybody else know that it's valid? What is consensus? Consensus is the process by which a network's participants come to agreement on some decision to be made. So in this case, in cryptocurrencies, in Bitcoin, consensus is agreeing on changes to the ledger of transactions. And traditionally, it's very simple. We place 100% of our trust in the bank. So again, back to the example of me and Diddy, we just trusted that Diddy's $3 would eventually go to me. So there's some solutions in blockchain. Some of them good, some of them better. There's the first one called the naive consensus concept. This is where everybody just accepts transactions as they come around without individually verifying that they're actually legitimate. So for example, in this network, it's very simplified. Let's say there's Alice, Dan, Carol, and Bob. If Alice is like, okay, I'm gonna send a Bitcoin to Bob, then everybody just sees that and is like, okay, I trust that Alice is actually gonna send 1 Bitcoin to Bob. But nobody actually double checks that that's true. So why is this a problem? There could be a double spend attack. So Alice, if she's like, okay, I promise 1 Bitcoin to Bob because Bob is giving me a laptop. But she's also like, okay, I also promise 1 Bitcoin to Carol because Carol is gonna give me a Tesla. Let's just say that that's the case. Then she only has 1 Bitcoin, but she already promised 2 people the same exact Bitcoin. So that's where the problem comes in, and it's called a double spend attack. So then there's another solution. We call this the democratic consensus concept. So instead of just having everybody agree like, oh, Alice's transactions are valid, we'll have proposers that broadcast transactions to the entire network and voters that choose whether or not to include them. So if you can see, there's links between Carol and Bob, Bob and Dan, everybody linked to each other. So Bob and Carol would be able to communicate that, oh, it looks like Alice was trying to send the exact same Bitcoin to both of us. Then everybody else is like, okay, that's not okay. Then they don't approve Alice's transaction, and then Alice's transactions would not be included in the block. But this is also vulnerable to a Sybil attack. So what if Alice is like, okay, I can create so many accounts, and then I could just say my transactions were valid over everybody else's no's. So as you can see, if Alice has 4 accounts, and then the entire network is only 3 other people, then she would still win by majority. So this is because public and private keys, creating them doesn't cost anything at all. So Alice can literally just make a bunch of accounts to vote in her favor. So then that leads to our Nakamoto consensus. This is what Bitcoin uses, and a lot of other cryptocurrencies use it as well. So this is the solution. Let's make the voters do a bunch of pointless brute force computation in order to cast a vote. So what does this mean? Okay, so in order to cast your vote, you have to have your computer complete some computationally difficult hash puzzle. So even if Alice creates a bunch of accounts, she probably doesn't have, millions of computers that can complete this brute force computation and cast the vote in time before everybody else realizes that it's not valid. Are there any questions? Yes. Yeah, so one of the main problems is that it's very energy inefficient because you're using all of these computers in order to even cast a vote. It's not very good for the environment. Any other questions? All right, moving on to identity.
All right, so now we're going to talk about identity, which is one of the main fundamentals of blockchain. So the motivating question behind the identity is, what makes an identity yours? And how do I actually own Bitcoin or any other crypto? So in the context of currencies, identity is used in many ways. For example, we all know receiving money. If I wanted to send Jake $5 on Venmo, I'll put his Venmo on my phone, and I'll put his, Jake Mark 1? And I'll send him $5. So, second bullet point, claiming and spending money, same thing. So your identity is your username or your phone number for Zelle, anything. And blame. So you can't blame me if you don't know who I am, essentially. If someone acts maliciously or scamming on Cash App or Venmo, you know who it is because you know their username. And then identity in our day-to-day lives. So houses have addresses and mailbox keys. Emails have aliases and passwords. And Bitcoin has public keys and private keys, which we will be diving into. So let's talk about identity at like a centralized institution. So for example, whatever bank you use, you'll have a username and password that is associated with yourself. And your username is going to be different from every other person's username. And then your identity, right? So how does a bank really know that you are who you are? They get your personal information, SSN, name, birth date, address, phone number, email address. However, this information is very important to yourself, and you are trusting that this bank will not act maliciously, but instead use this to verify who you are, which brings up a point of concern. So how does Bitcoin solve this? Well, they use public and private keys. So essentially, each identity is represented with a unique public key, and a corresponding private key is used to unlock that public key. So the mailbox is a perfect example for this. The mailbox would be your public keys. For example, if you go into a post office and you see all these mailboxes, you know which mailbox that you want to, which one is yours because they'll have a number on it. So this number essentially is your public key, and then private key will be that key that you use to open your mailbox. Going one step further, so if anyone wants to send you something, they can see this is your number, this is your mailbox number, and they can send you something using that. The private key is actually generated first. So using a very complex algorithm, the 256 bits are generated randomly. Don't worry, we'll go more into the technical stuff later. And then from that, using another complex algorithm, which I will go into later, the public key is derived from that. So you can think, a very easy way to think is that public key is for receiving and the private key is for redeeming. And public encrypts, private decrypts. That's a very simple way of thinking about this concept. So a few things to note. Since there's no personal information required, does that mean that Bitcoin is anonymous? And the answer to that is no. Bitcoin is actually pseudonymous. And the reason for that is you still have a public key. So there's still a way for knowing that whatever transaction, this person You might not know who the person is, but their identity is represented by this public key, which makes it pseudonymous and not anonymous. And are there any limits to the amount of accounts you can make? And the answer to that is also no. For example, I can go and create many private keys and public keys, and this will just give me a bunch of accounts. And this is also a security concern because one person can essentially make a lot of accounts, and they can take control of the network. But we'll go into that later. Is that in this lecture? No, it's not. We'll go over that in a later lecture. But this does bring a security concern. And finally, is there any restrictions on the keys that have been taken? There is not. And this is another security concern, but it isn't very important because this means that two people can have the same private key. However, the amount of private keys is 2 to the 256. That's the amount of private keys there are. So it's very unlikely that two people will have the same private key. What is the significance of anonymity? So the fact that no personal information is required makes Bitcoin, Ethereum, all this synonymous. And this is required for consumer privacy or fungibility. Since, again, you are essentially hiding behind this pseudonym, it's censorship resistant. You can post whatever you want, and there's no fear that it'll be tracked back to you. Again, there's no limit to the number of accounts. And going back to the fungibility, so this allows us to ignore the history of consumers, which is very important because essentially, suppose I was going to transact with a felon. If a felon was going to give me $1, I would probably be pretty suspicious about where that dollar came from and would not want to transact with that person. However, with Bitcoin, it doesn't matter who's sending you that money. As long as your Bitcoin is the same as their Bitcoin, that's all that matters, and you'll be receiving that Bitcoin no matter who it's from. Just one note, so if you see any of these dark slides, that means they're going to be highly technical and you won't be required to know this information, but again, it's very useful information. Yeah, so Bitcoin is hidden in the large amount of public keys. As I just said earlier, there's 2 to the 160 possible addresses, and this number is created because a Bitcoin address is created from 256 bits, correct? Yeah, 256 bits. And essentially a bit, for all my CS majors, again, is 0, 1, binary. So 2 to 256, that's the amount of possible combinations you can have, which means that it's practically impossible for any two keys to overlap using a random generation of the public keys. So it's very almost impossible for two people to have the same private key. For reference, the world's population is around 8 billion, and each person can have 2 to the 126 addresses all to themselves. So is there any questions about identity?
Once you know someone's public key, is there a way to trace that, personal information that's off-chain?
Well, that would be more of a question about like how that person utilizes their public key. Because essentially, if I create a if I create a private key and then a public key is derived from that, I will not want to tie my personal information to that. And there's no way, like there's no requirement, since again it's just the algorithm. So I would assume that generally would not really be a use case, just because people don't really want to associate themselves with their public key. So I would say there's no really way to trace it back to yourself unless like you tell me like, oh, this is my public key. Can you send me like a Bitcoin or something? Hopefully. Yeah. Mhm. Wait, could you repeat the last part of your question? Yeah, so that's actually a really good question, and this kind of is gonna, I guess, one of the initiatives goes into like off-chain and like cold wallets, which we'll talk about later. I will say that's also a barrier to entry. So a lot of these ways, like everything is a lot of it is online and like requiring a machine, but you can create a public and private key without using this if you can implement the algorithm. We can talk about that after class because it's a very complex algorithm that I don't want to like bore anyone down with. But yeah, but the answer to that, like cold wallets and hot wallets, that will be coming up in like 3 lectures or something. And that's one way that you can take kind of like the functionalities off the machine. Is there any other questions about identity? All right, let's move. Oh, does someone have a question? No. Okay. All right, let's move a review.
Okay. Does anybody want to tell me something they learned today? Okay. I'll tell you what you learned today. Okay, summing up Bitcoin. So there's an identity. You use your public key to receive Bitcoin from other people, and you use your private key to redeem it. Distributed ledger. Each party is responsible for maintaining their own copy of the blockchain. And trustless consensus. Transactions are approved via proof of work, which is something we'll define in later lectures, but that's essentially using a computationally difficult hash puzzle in order to cast a vote. And then this all deters double spend attacks. So that's what you learned about Bitcoin today. Are there any questions in general, either about the course, about the content, or anything? Yes. Yes, these slides will be posted, and the recording will also be posted in Media Gallery. Slides will be posted under Files on B Courses. Yes. I'm sorry? Wait, oh. Yes. Yeah, so not everybody in the blockchain or the Bitcoin network needs to have this copy. So these are only for the miners and the people who want to vote. But people, like individual nodes, for example, if I just own like a Coinbase account, that's like the simplest way. I don't need to own the whole blockchain. So it's just only the people who actually want to cast the votes have to own the blockchain.
And again, one thing is they're responsible and not required. So essentially kind of what she was talking about earlier, right, with the example with the 4 people, and they all have their own copy of the blockchain. So these are all the people that are engaging with that blockchain, right? Suppose that I decide like not to keep my copy, or I slack on that. Well, one of the benefits of having 3 other people is that they can help me update my blockchain if I want to like ever re-engage. So I guess one thing is, yeah, like I should be responsible for doing it, but if I don't do it, I still have these other people that can confirm that this is the correct blockchain. And also, that's a very low scale. Like in the real world, like there's many thousands of nodes that are working. So one person is essentially pretty insignificant in the grand scheme of things.
Yes. Are you saying, like, if a transaction was very back, then you wouldn't be able to? Right.
Yeah, that's a really good question. So basically, he was asking if, we have whatever, like 1,000, 10,000 people on the network, and they're all validators. Wouldn't it take a while to approve a transaction? Is that correct? Yeah. So essentially, I mean, we're going to get into that later, but that's kind of where you have proof of work and proof of stake, where you're actually going to be randomly electing a person. So you're not necessarily looking at all of those 1,000 nodes, if I'm not mistaken. And ultimately, there's like a certain threshold, which we'll go over in a later lecture, that you have to get approved to approve that transaction, and then that'll make that transaction go through, which is kind of like how we're able to avoid like going through every single node in the network, if that makes sense.
Yeah, we will be going over that.
Yeah, we'll go in a later lecture, yeah.
Yeah, so everybody has their own computationally difficult hash puzzle, so you wouldn't be able to share it. Yeah, exactly. Anything else? Okay. I'm just going to give you the attendance code. Okay, so the attendance code for today is Satoshi, and it's case sensitive, so make sure you capitalize the S. And this is going to close tonight at 11:59, so you might want to get your attendance code in right now. Yeah, it's like a quiz on the assignments tab.
Essentially, yeah, go to assignments and then go to today is the 31st. Click on that. There'll be access code. Type in Satoshi and then to say I'm here. Submit that, and you're gonna get 100%. You're gonna pass the class.
It should be the only assignment right now, so.
All right, do like class.
Thank you.
Thank you. Thank you, guys.
And we'll stay after. If you guys want to, if you have any questions, you guys can come up and ask any questions.
Yeah. Or I'll just go down there. It's till 7, but it's probably like not gonna ever take 2 hours.
It's like a lot of assignments and stuff.
It'll probably be like an hour to hour and a half.